Hi everyone, my name is Samantha Walter-Cano. In this presentation, I will be talking about Shiga toxin E. coli outbreaks in California's leafy greens. So to start off with a little bit of background information, what is Shiga toxin producing E. coli? So you may have heard that E. coli has a reputation of being extremely pathogenic and illness-inducing. The truth is that it is an extremely diverse group of bacteria, and we actually have some in our intestinal tracts right now, helping with digestion and breakdown of nutrients. So from all those groups of E. coli bacteria, there are only 6 known pathogenic types. The one we will be talking about in this presentation and focusing on is the Shiga toxin producing E. coli, or STEC. So this is the most commonly associated with foodborne illness, and as implied in the name, it produces a toxin called Shiga. The most commonly associated strand that produces Shiga is E. coli O157H7. So that's just a little background information. So what is the occurrence of STEC E. coli in food systems, specifically the leafy greens? So the article I chose, which was published December 2022, the authors discussed the occurrence of several high-profile outbreaks of STEC coming from California's leafy greens. And the article reviewed and discussed the factors involved in leafy green production that could contribute to an increased susceptibility to pathogen contamination. So a little more background information, 90% of leafy greens grown in the U.S. are harvested from California and Arizona. So you can imagine that contamination in just California could potentially impact those all over the country. So once again, the focus is on E. coli 10157H7. So to start off with, we will be discussing some of the major outbreaks. The first one is the 2006 outbreak, which led to 205 illnesses and hospitalizations and 4 deaths. The most recent one was the 2020 STEC outbreak, in which there was a total of 40 people infected. Half of those were hospitalized and 4 developed HUS. So you can figure that this is a serious problem, and so that is why the authors decided to try to find some patterns that have been observed with these outbreaks. So they discussed 3 patterns. So the first one is common geographical regions. In Arizona and California, you can imagine that the farms have similar climates, similar terrains, and all of the areas that have been recognized as the outbreak areas. Another issue is activities on adjacent lands, such as cattle production and migratory birds. So for example, that is your neighboring farm that could be involved with the livestock industry. So to talk a little bit more about that, they connect the use of adjacent land, which could or is usually used for animal production zones. So as it is with us, E. coli is prevalent in animal intestines. So that means that any kind of fecal material, any kind of digestive system could potentially contaminate the leafy greens through water or just through droppings in general. So that's one way. Wild birds also pose an issue due to foodborne pathogen carriage. Some birds are actually known to carry this bacteria and not get sick themselves. So any kind of fecal material, any kind of droppings, whether it's feathers or fecal material, could potentially contaminate the leafy greens. So another pattern is just agricultural water in general could be compromised with E. coli. It is known that irrigation subsystems are actually able to harbor E. coli and just bacteria in general. Some storage systems, such as reservoirs and dams, can also carry bacteria and pathogens. And then obviously open water systems such as canals and rivers are highly susceptible bacteria, and you will most likely find them in those kind of waters. So what is being done? After discussing those main patterns, the article talked about some things that can be done or should be done to prevent these outbreaks. So the first one is the Leafy Green Stack Action Plan, which was developed in 2020, and it's an FDA plan in partnership with EPA that assesses and improves the use of commercial sanitizers on agriculture irrigation water. There's also some regulatory responses to outbreaks, for example, just the opportunity for improved implementation of water protocols, system approaches to agriculture water sanitation, and potential future improvements to agriculture water safety. So the key one that the article hit on was just improved sampling and pathogen detection. So this is just being able to detect the pathogen in your water and in your water source before you use it in your irrigation system. So I have some two figures right here. The one on the left is just showing where the outbreaks are coming from, and as you can see, it mostly comes from California. The one to the right is just showing the trends of E. coli, of Stech E. coli in the US as well as in Utah. And as you can see, it just hits an upward, it's hitting upward, it's increasing. So this next image is similar to the second one, and it's also just showing the upward trend of cases. This one is a little bit more dated, but you can still see that upward trend. So here are my references. I use mostly CDC and FDA. So I just want to thank you guys for watching my presentation. I hope you learned a little bit. Thank you.